So we are now recording. I still have some people rolling in. So right there is the link. If you can log into that. I'm not sure if you need to hear it or not. You don't need to answer any questions this week in there. I just have a couple presentations. It's just easier because Live Lesson just doesn't like to share everything if I just share the whole screen. But I can also do that if we need to. So we were just talking about up in northern Nevada, it seems like everything's on fire. There's all those wildland fires. And then in southern Nevada, yesterday it was 120 degrees at 3 o'clock when I went to go pick up my daughter. And then at 8 p.m., when it was dark outside, it was still 108 degrees. It's crazy, just crazy. So we're just talking about the weather and stuff. And so I'm going to go ahead and get rid of this. I don't know what this is. There, just get rid of that. Oh, yeah, no. And people who aren't from here really, really suffer with, I mean, I suffer too, but, and I'm glad that you brought up the power thing. So yes, people are losing power. Well, in the north, because they're being turned off because of the fires and stuff. But in the south, the power is going out. They're doing like the rolling blackouts, just so people can, so we can conserve energy and do all this stuff. But yeah, and so if I get a little bit glitchy, I'm going to actually turn off my camera just so I don't get too glitchy. But I know the other day it was a little bit glitchy because of the power, because of the heat down here. It's just crazy. So I'm going to turn off my camera now just so it doesn't get all wacky. Anyway, I should take another picture to put in there because I'm not even smiling in that one. So anyway, so today, we are going to, look over some stuff, last week. Oh, first of all, don't forget to do your attendance. I saw people rolling in. Hi, welcome. So last week we talked about the sun and solar weather. And today we're going to go a little bit deeper and discuss solar flares and space junk, which is pretty cool. Can anyone here tell me, just in the chat pod, it's going to be unofficial, it's not going to be posted. Can anyone tell me, without Googling, what technology in your life depends on satellites? Does anyone know? What in your life? Wi-Fi? GPS? Good, right? So, I made this screen because it's interesting. Like, could something happening 93 million miles away mess with your phone, GPS, power grid, or even knock satellites out of orbit? So the answer is, you guys all have great answers in there, but yes, there are like a lot of powerful solar flares and things that erupt from the sun, which is 93 million miles away, right? And that can have an impact on your cell phone, GPS, power grid. It can even force satellites out of orbit. So yes, everything electronic, right? And so the way this happens is when there's a solar eruption, it affects the Earth. So like the phones and the radio, there are X-rays. Well, what about your cell phone? That doesn't have a cord unless you're charging it, I guess. But X-rays from like a solar flare travel at the speed of light. And so that can cause immediate like radio blackout, anything on the sunlit side of the Earth. And so it could lead to static or drop calls, just anything with a high frequency signal. But then when we look at like GPS, when you're looking at the solar energy and it hits that upper atmosphere, it scrambles and it delays the signals from traveling from, the different satellites and stuff. And so that can cause your GPS to, have the wrong location, different things like that. And so, yeah, and also the power grids. And so does everyone know what a power grid is? Power grid, it's the thing that we all need to have electricity, right? And so when we have these things, coming from the sun, oh, I have more people coming in. Hello.
Hi, Robles coming in.
Thank you. And so anytime we have those things from the sun, we just have, a lot of different things. But it also impacts, satellites that are in orbit. And so, there are a lot of things that are going on with this. So if something like this were to happen, And you could just put A, B, C, or D in the chat pod. But which would you miss the most? Something happened where it all went out. What would you miss the most? Would you miss GPS and maps? Or B, cell and radio communication? Or C, electric power? Or D, streaming internet and weather data? I know, right? You're not horrible. You're just being honest, right? That internet, that streaming, big deal. Yeah, it's a really big deal. So, and when you're looking at electric power, you need electric power for all of that stuff, right? So there are a lot of things that happen. I was just curious on what you would miss the most. Okay. So I just kind of tossed this in because this isn't covered a whole bunch, but there are a lot of different agencies that monitor and forecast, weather and things that are happening, solar storms, but they're constantly monitoring the sun. And this is all over the world, right? And they're forecasting different solar storms. It's kind of like predicting a hurricane. It helps protect satellites and power grids and astronauts, things like that. And so in the future, as we get more data and we learn to do more things, understanding the sun and earth connection will really be key to protecting our technology and understanding how our climate, changes all the time. There are so many variabilities of that. There's space weather data. That's one thing that I have in a couple slides from here. But there's a lot of space weather data that you all can look at. You think, just, NASA and those fancy people all have this information. But there's a lot of data out there that public people can use. And there's a lot of information from solar observations, satellites, gives us a lot of information. It shows us solar radio flux. It shows us sunspots. It shows us, different imagery and a lot of other things. And so they use that to produce forecasts like, monthly sunspot number forecast or different things. And as a matter of fact, as I was getting ready for this, I read that sunspot numbers represent one of the longest continuous climate records available. Fun fact, right? Okay, so I have a solar flare. All of the videos I have in here are like 1 minute, 3 minutes, I think is the longest, but you don't have to answer any questions in there, okay? I just want you to be able to hear it. So the next thing coming up is a solar flare video. Just for those who aren't really sure what a solar flare is, what happens is the sun, always shapes our world. There's solar storms, there's a lot of different cycles, and these can really be disruptive, but they can also do some cool things. So here's a quick video. Let me know in the chat if you can hear it. This isn't right. Okay, so the Heliophysics Observatory for Space Junk, this is in the wrong spot. So we'll have to come back to this one because this is out of order. Here's the video. Okay, so for those of you who can hear it, is it because you're signed in? For those of you who are signed into Nearpod, can you hear it?
A solar flare is basically an explosion on the surface of the sun, ranging from minutes to hours in length. Large flares can release enough energy to power the entire United States for 1 million years. Flares happen when the powerful magnetic fields in and around the sun reconnect. They are usually associated with active regions, often seen as sunspots, where the magnetic fields are strongest. Flares are classified according to their strength. The smallest ones are B class, followed by C, M, and X, largest. Similar to the Richter scale for earthquakes, each letter represents a 10-fold increase in energy output. So an X is 10 times an M, and 100 times a C. Within each letter class, there is a finer scale from 1 to 9. C-class flares are too weak to noticeably affect Earth. M-class flares can cause brief radio blackouts at the poles and minor radiation storms that might endanger astronauts. It's the X-class flares that are the real juggernauts. Although X is the last letter, there are flares more than 10 times the power of an X1, so X-class flares can go higher than 9. The most powerful flare on record was in 2003, during the last solar maximum. It was so powerful that it overloaded the sensors measuring it. They cut out at X17, and the flare was later estimated to be about X45. A powerful X-class flare like that can create long-lasting radiation storms, which can harm satellites, and even give airline passengers flying near the poles small radiation doses. X flares also have the potential to create global transmission problems and worldwide blackouts. The seriousness of an X-class flare pointed at Earth is why NASA and NOAA constantly monitor the sun. NASA's heliophysics fleet of spacecraft see the sun from every side and in many different wavelengths. This unprecedented coverage is enabling scientists to predict and detect space weather events like flares and CMEs with ever greater accuracy. With advance warning, governments and companies can take steps to protect their technological infrastructure so that the worst scenarios will never happen.
So that was that video. So it's kind of interesting. It's just kind of an overview. I also, I was telling you that there are, websites that you can go to, see what's going on in space. So I'm going to show you a website where you can go and check out current space weather at any time, just to see what's going on at this exact time. So, you can look for, there's a lot of different things on this website, looking for like solar flares, sunspots, geomagnetic activity, auroras, which are pretty cool. You can even look at earthquakes and volcanoes. So as I go through it, just kind of look for different things. So I'm hoping this works on this. So this is, okay, so you see that one, right?
Song?
All of this stuff right here. So this shows you what the space weather is right now. And you guys can go to this link. I put it on our lesson intro page. And you see it right here. It's orbitalradar.com. But you see a lot of different things. So you see like what's going on right now. It says all quiet. So there's nothing cool going on. Even though there's nothing dramatic happening right now, that's data too, because, you don't want something dangerous every single day. But as you scroll down, you kind of look at, like the different scales and has all of this stuff. It shows the forecast, shows like the auroras and stuff. That's kind of cool. You can rewind the storm. It has, so my chance of seeing an aurora tonight is 0%. Who would have thought, right? It is always 0% for me because I'm in Las Vegas. I've heard that some people in Reno have seen it though this year, which is really kind of cool. But yeah, you always think about Alaska, right? Yeah, I've never seen one either, even though it's my favorite. But then as you kind of go through, you look at like a solar storm, things that it actually impacts on Earth. It tells you how. But then it even has, live things that are going on. So, you can look at sunspots. This is a pretty cool picture. This one here is really, so like you can click on these. Here's where you'll click on to see, what's going on on Earth. Tells you where the aurora is going to be. But it has a lot of really cool information. So if you're ever bored, you just kind of want to see what's going on with the sun and our Earth, kind of check out that website.
How do I get there?
Oh, you go to orbitalradar.com and I'll have it on here. I'll go ahead and just paste it right here for you, but I'll have it on the lesson intro page. I know I want to see one too, but So yeah, so it has a lot of really cool stuff. So let me go back to this lesson. Oh, can you still see this right here? The space weather now? Okay, good. So that is the website, and you can click on it. Everyday people can. And so I wanted to include this because, yeah, I haven't actually seen one of these in real life, but not all outcomes of space weather are negative. So auroras are my favorite. Natural, beautiful. It's a consequence of space weather, right? But kind of like the rainbow is here on Earth, right? The way they develop just from like a collision of like all the charged particles from solar eruptions, and they collide with the Earth's upper atmosphere. And so they have a lot of beautiful light shows. I know up in Wisconsin, they have, they see them as well. So there's a lot of different things, but there are also radiation risks for like astronauts and airline passengers and stuff who are doing, taking like flights over the polar regions. So why do we care about all this? Why do we care what the sun is doing? It's a zillion miles away, right? And so someone asked me last week in this class, what is the impact? I looked it up afterwards, so I knew for sure. The direct biological danger at ground level is very low, but there's a lot of the technological impacts that can be very significant, as we've discussed. Anytime there's a geomagnetic storm, it can disrupt satellites, GPS, power grids, all the things that we've talked about. And the risks for astronauts and people on flights and stuff. Is there anyone in here who uses Starlink? Has a Starlink at their house? Yeah? Well, this next thing
Never heard of it.
You've never heard of it. Okay. Starlink. It is like Elon Musk's, all the things that Elon Musk does with his satellites, right? So I'm going to actually share I think I can play it through your assignment. So I'm going to see if I can do this. Okay, so y'all can see this, and I click the button that says play sound too. So instead of doing the video separately, I'm just going to play them right in here. And, hopefully you can hear them. Let me know if you can't, and we'll just troubleshoot around this, right? But, when you're watching these videos, we're going to go through, all the things like solar storms, what they disrupt. And so, what? Okay, so this
increased solar activity is having a dramatic impact on satellites orbiting Earth, particularly the Starlink network. A new NASA study reveals that geomagnetic storms caused by solar eruptions are accelerating the re-entry of these satellites, pushing them out of orbit faster than expected. The study, led by Denny Oliveira at NASA's Goddard Space Flight Center, analyzed 523 Starlink satellites that re-entered Earth's atmosphere between 2020 and 2024. As the sun approaches the peak of its 11-year solar cycle, known as solar maximum, solar flares, sunspots, and coronal mass ejections are becoming more frequent and intense. These events release high-energy particles that heat Earth's upper atmosphere, causing it to expand. This expansion increases atmospheric drag on low Earth orbit satellites, requiring constant adjustments to maintain proper altitude. If not corrected, the added resistance causes satellites to fall back toward Earth. While all low-orbit spacecraft are affected, Starlink actually provides a unique lens for study because of its massive scale. 8,873 satellites launched, with 7,669 currently operational. These satellites aim to provide global high-speed internet, especially in remote regions. However, the increasing re-entries during this period of intense solar activity really highlight a growing challenge for satellite operations. Additionally, the sheer number of satellites is raising concerns about space debris and interference with astronomical research. Reflected sunlight from these satellites often disrupts observations, making them a nuisance for scientists. Despite their benefits, the growing risks and complications posed by increased solar activity and satellite density present significant concerns for the future of orbital operations.
Okay, so we kind of have watched that. This is all on your lesson intro page as well. But we've watched that, so we know that all of the solar storms, all of that stuff has an impact on satellites out there, right? And they have an impact on your life like we talked in the beginning. So we're looking at all of that.
So does that mean they have an impact on the moon?
Yes.
Yeah. So the other thing with this, though, is that the other part of this is space junk, because this is one of my favorites. Because when I first started teaching science like 20 years ago, I would talk about space junk, and there was space junk in there, but I would talk about it and everyone would just think that that was just something so far out because no one ever heard of it and there wasn't a lot. Now we have so many satellites out there. I mean, Elon Musk, he's sending his own stuff out there, right? He's not the government. So there's a lot of things going on. But when you're looking at all of the space junk, there are things like tiny fragments that can carry enough kinetic energy to damage spacecraft. Okay. So I'm going to click on this real quick and we'll get through this. I think this is the last video. So
space is getting crowded. Right now, there are close to 12,000 active satellites orbiting Earth. But it's not just empty space between all that important tech. Floating amongst them is 8,700 metric tons of debris, both accidentally and intentionally left behind by past space missions. And it's cruising at speeds of 17,000 miles per hour, threatening to endanger astronauts and destroy the very satellites that modern life depends on.
The Space Surveillance Network can detect objects in low Earth orbit all the way up to geosynchronous orbit that have a minimal size of 10 centimeters cubed. Of the 47,700 objects currently that we are tracking in space, about 39% or 18,800 are considered debris.
That's almost 20,000 objects the size of a softball or larger that we need to keep track of to prevent catastrophic collisions. Less than 1% of the estimated total pieces of debris.
The remaining 99% are the debris that we don't even know where they are or how to track them.
The small debris can cause tremendous damage because of their high velocity. It's like a rifle bullet colliding with a spacecraft.
It is essentially an invisible hazard in space.
In 2024, a satellite from telecommunications provider Intelsat broke apart after what was likely a space junk collision. And in 2022, astronaut Frank Rubio saw his stay on the ISS extended after small debris punched a hole in the craft that was scheduled to take him home.
3 months since this Soyuz vehicle began leaking coolant from its heat-dissipating radiator.
The data that we provide is to inform spacecraft owner-operators to maneuver out if there's a potential conjunction or collision that is incoming.
Because debris smaller than 4 inches has a smaller area and reflects less light, radar and optical telescopes used by agencies like Space Force have difficulty spotting them.
We can't maneuver or make decisions based on what we don't know, and so it is potentially an accident just waiting to happen.
And every collision in space creates more debris that can cause further havoc, fueling a chain reaction known as the Kessler syndrome. If business continues as usual, the amount of small debris will continue to multiply in orbit and could eventually threaten the sustainability of satellite launches and space travel.
In order for us to have operations that are safe in space and can last a long time to make economic sense for stakeholders, we have to provide a very safe environment for them.
So with that, I'm going to ask you a question. You don't have to go into the Nearpod, but I am going to go back to the Nearpod. Okay, so with everything that you've seen, what do you think is more dangerous at orbital speed? A marble, a baseball, or a bowling ball? Darts, good. Yeah, bowling ball. So yeah, you know what? There is no answer because it depends on so many different things because you have to look at force. So, you know, there's force means mass times acceleration. So if they're all they're all accelerating at the same, then yeah, the mass would probably be the bowling ball, right? But they could be going different speeds. So a bowling ball going at accelerating in different pace is, may not do as much damage as something small. I mean, think about it this way. If we're at the park and let's say I picked up a basketball and threw it at you, or like a little rock, which one would hurt more? Well, it depends. Think about a gun, shooting a gun, like with a bullet. If I took a bullet and I threw it at you, it would probably do less damage than a marble, right? It's because when it's shot from a gun, the amount of force is what does the damage. And so it's the same thing in space when you're looking at the mass and acceleration. Okay. So we did all these videos on our own. Okay, so the discussion activity, here's where you can answer this question, right? So which do you think will have the greatest impact on satellites in the future? So in the chat pod, just go ahead and type in solar activity or space junk. Which one do you think will have the biggest impact in the future? Not today. Well, maybe today. Doesn't seem like there's a whole lot going on in space, though, today. Space junk? Well, there's arguments for both. I mean, if you look at, there's not, this is the beauty of a discussion. You do not have to pick both sides. You choose one side and you back it up. There are no wrong answers as long as you choose something and you back it up with facts, okay? So that's what your grade will be based on. But if you look at solar activity, we saw a lot of different things, looking at, radiation, electronics damage, radio, GPS, the heating of the atmosphere. There are a lot of different things, a lot of events that can affect many satellites at one time, right? But on the same token, space junk, even the tiniest little piece can cause a lot of damage to the satellites. So, there's collisions at extreme speeds, tiny pieces that can cause a lot of damage, a lot of small debris that we can't track. And then every time there's a collision, what does that create? More space junk, right? So those are the things that you're going to look at when you are answering the discussion question. I'm not going to go back to the other page because I don't think we have enough time. But here is the discussion at the end of the unit. Okay, so we basically, being in this live lesson, you've gotten more already because you've watched the 2-minute video and the 3-minute video. So you have the information for those. But it asks you a couple questions, and you just have to choose one and then detail why you think that would have the biggest impact. So does anyone have any questions? Okay, one other thing I want to mention, and I put this on the lesson intro pages, but for the vocabulary, are there any people in here who are doing Mr. Evans stuff where you're going in and, doing the quizzes and all of that fun stuff? Let me see, I think I have the page here. Let me look. Yes, under sample work. Academy of Heroes, thank you. So with the Academy of Heroes, I'm going to share my whole screen and see if it lets me. Right here you have, if you're doing that, you can go ahead and you can do the vocabulary as it is. Or, I don't think this wants to share all of my stuff. Okay, here, I'll just share my lesson. Okay, so if you're not doing it, you do not even need to listen to this because it might be confusing, but you can do the vocabulary words where you just do the vocabulary matching at the end of the lesson. If you're doing the Academy of Heroes, you can go ahead and send me 3 of your patrol results in webmail, and I'll give you credit for the vocabulary. And so for those of you who are doing it, that is going to be that's on every one of the assignments now. And then what else do we have coming up? Okay, so you have this discussion, you have the quiz, and we reviewed that last week. And you have right here, you can go right there and go over the questions. And then we have the discussion, well, you have your sample work, but then you have the discussion. And then you do not have a test in this unit. So your discussion is the biggest thing in this unit. And then we'll move on to unit 4 next week. So does anyone have any questions? Okay, I'm going to go ahead and turn off the recording. If you have questions, stick around, and we'll go over them. And if you don't, have a wonderful day then. And let me stop recording.